Welcome back to my channel. Today we're going to be talking about chain rule. So today we're going to be talking about this very fundamental rule called chain rule. And chain rule is something that we can easily add into different functions kind of whenever and wherever, and they're more likely to be seen in the real world than things at their base level. So all the functions that we have been dealing with have been x to a power, so like x to the fourth. But we know that we can have something else like x plus 5 raised to the fourth power. Those kinds of things are things that we have that are compositions of functions. They have inside and outside functions. This is where we're going to be using chain rule. So chain rule is where we see functions inside of functions. And when we deal with these functions, we kind of have to peel back all of these pieces kind of like layers. So one of the ways that I like to describe this is a peanut M&M. So when we look at a peanut M&M, we see the outside shell first. When we try to bite into it, we bite through that candy shell, but the chocolate and the peanut inside stay the same. Once we are done biting through the candy shell, it's now time to bite through the chocolate shell. But as we're biting through that, the peanut stays the same. And then finally we bite through the peanut, causing us to have gone through everything in this piece. When we look at chain rule, it's very similar. So when we take the derivative using chain rule, we need to take the derivative of the outside first. So in our case, we're going to be looking at f prime of whatever our function is. We need to keep the inside of everything else the same. So we leave g of x here. Well, we've dealt with f of x now, so now we're going to look at the derivative of g of x. The derivative of g of x is g prime of x. When we're doing this, we're going to be multiplying them together. We can kind of peel this back, kind of like an onion. So every time we do something, we're going to peel back a different layer. So when we look at these problems, what we're going to want to do is kind of decide what's our inside function and what's our outside function. So our first one, f of x is equal to cosine of 3x squared. Parentheses kind of give us a lot when we're looking at this. So if we think about our inside function is the thing inside of everything else. In this case, it is 3x squared. Our outside function is going to be that cosine. So cosine and then of whatever is inside of it. So when we deal with this, we are going to be dealing with the derivative of cosine first. So f prime of x is equal to, the derivative of cosine is negative sine. We keep the inside the same, so that 3x squared is going to go right inside of those parentheses. And then we're going to multiply it by the inside's derivative. Well, the derivative of 3x squared is 2 times 3. And we take 1 away from our exponent, so 6x. We could rewrite this if we really wanted to as negative 6x sine of 3x squared, but everything just depends on what we need to do with it and kind of how a multiple choice problem may give us answers or what we need to do with it next. Okay, so we're going to do the same thing with this one. So we need to find the inside function and the outside function. So when we deal with things like this, sine of x cubed, we can kind of think of this as sine cubed of x or sine of x all cubed. So an easier way to actually look at this problem is to rewrite it as sine of x raised to the third power. When I do it this way, I can really see an inside and an outside function. So inside we have sine of x, and outside we have this to the third power. So g prime of x. When we're doing with this third power, we're going to use power rule like we would normally do. So 3 times the thing up front, which is 3, or it's 1, so 3 times 1 is 3. And then we take 1 away from our exponent, so 3 minus 1 is 2. We keep the inside the same, so sine is inside of my parentheses, so sine is going to stay inside of these ones that are being raised to the second power. Then I multiply this by the derivative of the inside. The derivative of sine is cosine. We can only do so much rewriting this one. The only thing I would probably do is change the squared to sine squared of x instead of sine of x all squared, but they mean the same thing because of where parentheses are, so it doesn't matter either way. Okay. So we have the natural log of 4x squared minus 12. So our inside function is 4x squared minus 12. Our outside function is this natural log. So each of x equals. Normally when you take the derivative of 1 over of natural log, it's 1 over x, x being the inside function. So this time, 1 over our denominator is our inside function. So all of this here is our inside function. So 4x squared minus 12. We need to multiply by the derivative of 4x minus 12. So I'm going to put a parenthesis here. The derivative of 4x squared is 8x minus 12. We can just kind of leave it. So we have 1 over 4x squared minus 12 times 8x, or we can write it as 8x over 4x squared minus 12. I could simplify this. Looking at this, we have 4 in common with all of our terms, so I could write this as 2x divided by x squared minus 3, but we can also leave it like this. It doesn't really matter either way. When we get to things like this, sometimes you will see natural log being written like this, the derivative of the natural log of u, where u is any function at all. And we know that this would be u prime divided by u. This comes from the fact that u is the inside of our function, where u prime is the derivative of the inside. So we end up getting the same things. We just look at it in a slightly different way. But that comes from chain rule. E to the x is similar to natural log. We have a way that we can look at it, but it boils down to our inside function and our outside function. If we can't tell which is our inside, one way that we can do this is by plugging in x. If I were to plug a number in for x for this problem, I would need to deal with that exponent first. So the thing inside the exponent is going to be our inside function. The thing outside, the thing I would deal with afterwards, is that e to a power. So when we take the derivative of e to a power, it is e to that power. So I have e to the power of 3x squared plus 14x. Then we're going to multiply this by the derivative of the inside. So 3x squared, 6x plus 14. There's really not a lot we can do that. The only thing I would probably do is maybe move 6x plus 14 to the front. That's it. Just like with natural log, we could write this as e to the u power, where we would get e to the u times u prime. But it is just chain rule. So it's just knowing how to apply chain rule and being able to use it. The last one we're going to look at here is this one right here. So my inside versus my outside. So inside, if we look at their inside here, everything inside of the parentheses is that x cubed minus 5x squared. Outside is everything outside of the parentheses, which is that 4 times something to the 10th. The 4 out front can kind of be left as a coefficient. We can just leave it in the front, or we can put it with our outside function. It doesn't really matter either way here. So k prime of x equals the derivative of 4 times something to the 10th power. We're going to use power rule, so 10 times 4. And then we're going to take 1 away from our exponent. The thing inside is what it was originally. So we have x cubed minus 5x squared. And then we're going to multiply it by the derivative of the inside. So the derivative of the inside, the derivative of x cubed is 3x squared. The derivative of 5x squared is 10x. And I can leave it like this. I can move stuff around, but overall we can leave it like this and just look for the best option if it was a multiple choice question. So these are all kind of like, we only have an inside function and an outside function, but like I said, chain rule is kind of like peanut M&Ms, and there can be more layers than just 2. So sometimes we have more than just an inside function and an outside function, but we'll save that for next time.